Section 1.2, part 4 of our videos for this section. We're going to cover a few more examples on finding x and y intercepts, both algebraically and graphically, and then take a look at the idea of local extrema. So starting with this, starting with example 6b, we have the directions to say find the x and y intercepts of a function h of x algebraically. All right, so to find the x-intercept, it's a bit more work than the y-intercept if you're going to do this algebraically. To find the x-intercept, y equals 0. So we're going to have h of x, which is equal to all of this, x minus 3 times x plus 2 times x squared minus 4 equaling 0. And then we're going to solve this algebraically. Because it equals 0 and all of these are factors, we can separate them into 3 separate equations and solve. So x equals 3, x equals -1, then x squared equals 4. We take the square root of both sides, and because we're taking a square root, we end up with x equal to plus or minus 2. I'll get this written down. So we have 4 x-intercepts. We have the x-intercept 3, 0, -1, 0, -2, 0, and 2, 0. For y-intercepts, when you have nice functions like this, it's very quick to find a y-intercept, x equals 0. So that means that we're going to plug a 0 in for x throughout this entire function. And we're going to end up with -3 times 1 times -4, which works out to 12. So the y-intercept is at x equals 0, y equals 12. Taking a look at part C, we are to find the intercepts graphically. So I'm going to put this on my calculator. I'm going to have x to the 4th minus 5x to the 3rd minus 5x squared plus 23x plus 10. Now, the last time I used my calculator, I did not zoom it back to normal. So when I graph it, it's still in that zoomed box that I used in the previous video. So I'm going to go to zoom and hit zoom standard or Z6, and that's my graph. If we wanted to find the x-intercepts, at least 2 of them can be found by inspection, but let's just use our 0 function underneath the second trace, and then 0. Once again, this is to find the x-intercepts. So I'm going to hit second trace 0, that's number 2, and I'm going to move my cursor or my spider to the left. I'm just starting with the left intercept, the leftmost intercept. I'm going to move my spider to the leftmost intercept. I'm going to hit enter to the left of it, enter to the right of it, and I'm going to hit guess, and I get a 0 at -2, 0. Sorry, my page moved. Then I'm going to do second trace number 2 again, and rinse and repeat. This time to the left of this intercept is going to be below the x-axis, so I'm going to hit enter. Right of this intercept is above the x-axis, and hit enter again, and I have an approximation of -0.414 as that x-intercept. Moving on to the third intercept, second trace 0. This time the left intercept is above the x-axis. Notice I'm just hitting the left button. I know it took a while for Mr. Spider to appear, but there he is. The left intercept is above the x-axis. The right intercept is below it, and I'm going to hit guess, and I'm going to get 2.4140 as my third x-intercept. And finally, this one, by inspection, I think that's a 5. But to make sure, let me do second trace 0. Move my spider to get the rightmost intercept. There we go. And it hopped right to it, 5-0. I don't have to do anything, so I can hit second quit and get out of that. So these are all x-intercepts. We know they're x-intercepts because the y values are 0. Then to get the y-intercept, we're going to have to zoom out on this particular graph. The y-intercept, well, maybe not. I'm sorry, I needed to correct myself. You might be able to see the y-intercept right here. I'm going to do a zoom box, zoom number 1, and I'm going to take my spider up. Give me just a moment to move Mr. Spider around. I'm going to hit enter. And when I hit enter, it's going to drop a box there. And I'm going to move to the right, to where I'm to the right of the y-axis in this case. And when I get to the right of the y-axis, I'm then going to drop the box using the lower one. I lost my box. Give me just a moment. Once my box is drawn, I hit enter. And it zoomed right there. I think the intersection is right here, but I really can't tell. So I'm going to do a zoom out. I did need to zoom out earlier to get the intersection in, but there's the intersection. So now we can do box if you want. And I'm looking at my values down here as I go up the graph. Let me hit trace. So I go up the graph. My x value is negative here, and it crosses over and it's positive there. So I'm betting that my y-intercept is at 10. But the only way for me to find out, to be sure, is to do a zoom box again. I'm just going to get a few of these in the frame. See, make sure it's at 10. Drop my left. I'm going to go over here and I'm going to drop my right. And that's got the y-intercept in there. And yes, it's at 10. So the y-intercept is at 0, 10. All right, so I'm going to do a zoom 6 as well to get it back to its standard frame before I do anything else with it. The next topic on this page is about local extrema, which simply put is the highest point on the y-axis or the y values that our graph reaches, or the lowest point in y values that our graph reaches. So extrema is for the extreme values, and we're going to talk about local maxes and local mins. For a local max, it's our highest point, and when it's a local max, that means that all the little points around it are smaller. And then for a local minimum, it's our lowest point. And what that means, here's a local minimum right here. What that means for that local minimum is that if I took a look at this graph, all the points around that local minimum are graphed higher in their y values. So on example 7, it says identify the local maximums and local minimums for the function in the graph below. So locals, we're not interested in what's going on over here. We know that it's going up towards positive infinity on both of these sides. We're not interested in that. We're interested in, if we just took this band right here, we've got an extrema at this point, that's our minimum, and then we have another extrema right here, that's a minimum. The minimums, this extrema happens at -1, -2, and there's another minimum at 2, -1.5. So those are our valleys, so to speak, the low parts of our graph. And then to get the maximums, or local maximums, I should say. We see a hilltop, and it happens right here. So as we take a look at this peak right there, all the points around it are lower. So it hits a high point at at 0.5 on the x-axis and 0.5 on the y-axis. So our local maximum is 0.5, 0.5. Our next video will continue the discussion of extrema and then move on to increasing and decreasing functions.